Right, on the other day we were focusing on this LDP protocol, label distribution protocol, which is actually MPLS. Actually, you see, when you enable MPLS, I told you this gets enabled by default. MPLS is just a name, multi-protocol label switching, but MPLS uses this behind the screen, and we also saw it uses TCP 646. But initially, to form neighbor, it cannot use TCP, right? For TCP, you should have the neighbor to negotiate. So what exactly happens is it uses UDP and uses multicast distribution 224.0.0.2 to negotiate and form neighbor. Once the neighbor is discovered, the further communications will be TCP based. 646 is the port number. This is the port number destination. The source from the initiator will be always a random port number, which is a normal TCP behavior. Next, like LDP, I also told you there is another protocol by Cisco. Anyone tell? Tag distribution protocol. Well said, TDP. And this also uses TCP 711 as the port number. Both are equally good. The only reason why TDP is not popular is when we have multi-vendor device, then that will become a problem. Neighborship won't come if one is LDP and the other one is TDP. But on one single router, you can have one interface with TDP, the other with LDP, no problem. But over the link, you should have same on either side of the link. And we also saw very important role of label distribution. We saw that the routers won't use their own label to send packet. Before sending the packet, they have to put some label, and they don't use their own label. They put the label learned for that destination from the neighbor router. Puts that label and sends to the neighbor. Neighbor, when it receives the packet, it opens the first layer, second layer. Immediately after second layer, it finds the label, which it already knows. And it knows the label belongs to so-and-so destination. So it uses the other label given by the downstream neighbor to swap with the incoming label. So labels, when you notice, no router uses their own label to push or pop. Push is nothing but adding label to the MPLS header. Swap is nothing but swapping with the label of the downstream. And what is pop? That's what we are going to focus today. MPLS pops the label. Where it will pop? You see, these are the loopbacks on these routers. Now, let's say the label for 4.4.4.4 locally is 30. Here locally is 35, 25. Here locally is 18. Here it will be 3. I told you from label 1 to 15 are reserved. This is one of the reserved label. And here we are focusing on 4.4.4.4 network only. Do not focus on any other network now. So what happens when R4 advertises label number 3? R3 learns that when I send any packet to R4 with the destination address 4.4.4.4, I should not use MPLS header. I should not insert MPLS header. I need to pop. That's what this is signaling. Label number 3 signals R3 that you should not attach MPLS header when you are sending to the destination 4.4.4.4. R3 is going to pop the label here. Label is pushed here. From outside, a packet is coming, a normal IP packet is coming where there is no MPLS. The packet comes from there. And this is the first router where MPLS starts. MPLS header is pushed here. And MPLS label is swapped here. Popping doesn't happen on R4 to this destination. It happens one router before the final destination router. This is what we call it as PHP. One router before the final destination pops. We call this as PHP, penultimate hop popping. Penultimate hop popping, PHP. Why it is hopping? Why it is popping one hop before the final ultimate hop? We are going to discuss that. But before that, this push and swap and pop. So the pop is not happening on the egress router here. What is the egress router? R4 is the egress router to the final destination. It is not happening on the egress router, but one router before the ultimate hop. That's why it is called as penultimate hop popping. Okay. Now, why is it? We'll see in a few minutes. But before that, going one step backward, a packet is coming, and R3, R1, before forwarding the packet out, it adds an additional MPLS layer, but provides label number 25. Because through LDP, the labels are distributed. Router 1 knows that according to router 2, the label for 4.4.4.4 is 25. Likewise, router 2 also knows that according to router 3, the label is 18. Router 3 knows according to router 4, for 4.4.4, label is pop. No label. penultimate hop. So how it knows? Label number 3. Label number 3 you will not see in any output. But in a Wireshark, when you capture, you will see there. So this R4 sends the label number 3. And you won't find it in any debug, nor in any output on router 3. You will only see PHP or POP, depending on the operating system. You will see mostly POP. Now, when the packet is sent out from R2 to R3, it is going to put label number 18. When the packet is sent out from R3, it is simply going as an IP packet. It's going as an IP packet. No label header, no MPLS header, nothing. That is because of the PHP. So I told you, no routers use their own label to attach. R1's own label is 30. Is it attaching 30? No. R2's own label is 25. Is it attaching 25? Is R2 attaching 25? No. Right? R3's own label is 18. It is not attaching any label before sending to R4. Okay. I hope you understood how these labels are used. Now let's focus on this PHP, penultimate hop popping. If PHP don't happen, what will be the result? Let's try to understand that. Let us say there is no PHP and label is 31. Label is 31. So R3 now puts label number 31 and it is sending to R4. Now R4, on receiving this packet, it will check layer 2 and after it will find one MPLS header. MPLS header says label number 31. Label number 31 means what? 4.4.4.4. My question to you is, will there be a label for 4.4.4.4 on R2? Sorry, R4? No, because it is not given by someone. It is local. So because there is no outgoing label, R4 need to now look again the packet for more information. So there is no more information in MPLS. It will go to layer 3 header now. Reading the whole layer 3, it knows the destination 4444. And to go to the destination 4444, it looks into the routing table and then it sends the packet out. You see, you could have avoided that MPLS header reading because it's of no use. That didn't serve the purpose. Because to know the destination, you have to look into the routing table here. Without looking into routing table, router 2 was able to forward the packet to router 3 because there was one label called 18. But for router 4 to deliver the packet, there is no label. So it has to do again one more lookup again to the routing table because there is no control plane information in MPLS. Only the layer 3 routing table has got that control plane information that controls the traffic to the final destination called loopback 0 interface. What do we see here? We need to avoid this two lookups of MPLS and IP. You can avoid you can make it as one lookup, just IP, because there's no use of having that layer, MPLS layer. It is adding more complicated complexity to R4. So better when R4 receives, let it receive as an IP packet so that it no need to go through the MPLS control plane and then come out of it and then going into the IP control plane. You see? So R4 can easily forward the packet to loopback interface when the IP packet is received with no MPLS. It will quickly know the destination from layer 3 header and go to the routing table without wasting on MPLS database, without wasting time on MPLS forwarding table, MPLS control plane, without wasting time there. It goes straight to the IP control plane and deliver the packet. See, so here we have seen that R4 works better when it receives as an IP packet instead of MPLS and IP. That's the reason why MPLS is designed to advertise label number 3 for the connected network. For 2.2.2, for 3.3.3.3, router 3 will advertise label number 3. For 2.2.2.2, router 2 will advertise label number 3. You see? So the other routers, the upstream routers, while forwarding the packet, they don't need to add the MPLS header. They can simply forward it as an IP packet. What do you see now? What did you learn here? PHP is good. And that PHP is signaled by label number 3. Now, I'm going to something introductory in MPLS. You see the labels. MPLS assigns label both on routing table, both on the router as well as it inserts the MPLS header on the packet. When you enable MPLS, these are the two things that happens. One, adding labels to every single network that is learned in the routing table of each router. Second thing is, before sending the packets out, attaching the MPLS header to the packet. Two things happens, right? Why we need this? Someone tell? Why we need these attachments? What is the benefit of this MPLS? Fast. But you know one thing, even before MPLS you enable, the routers have got Ceph in it. Cisco Express Forwarding. Cisco Express Forwarding is a buffer that maintains the layer 3 routing information in layer 2. Where is CEF? L2. What it contains? The routing table. So when a packet arrives, the packet is not going through the routing table engine in layer 3. It is not going to every single line in the routing table to see the maximum prefix match and then the exit interface, and then no, not like that. Routing table is important. Without routing table, routing is not possible. But that routing table, if it is there on the top only, there is a delay. After processing layer 2, it has to go through the layer 3 routing engine to know the exit interface, and then again come back to layer 2 and then go out. It is taking a lot of time and CPU. So what Cisco has done, they designed a buffer where anything comes in the routing table in layer 3 will be mirrored down into a table called CEF in layer 2, so that when a packet is processed in layer 2 itself, it will know the exit interface. It no need to go through the second layer of engine. The first layer of layer 2 engine itself will also show you the exit interface on the route for the destination. So your routers are already fast. To make it much more faster, you enable MPLS. So when you enable MPLS, the labels are assigned, but not to layer 3 routing table engine. Why? The packets are not going to go through it. The labels are not assigned to the layer 3 routing table engine because the packets are not going to go through layer 3 routing table engine. It is going to only refer layer 2 CEF table. So when you enable MPLS, labels are assigned to the CEF entries only. But CEF is not when there is no root in the routing table. CEF depends on the routing table, no doubt. You're not replacing routing table here. Routing table is important to update CEF. If your routing table is faster, your CEF gets updated faster, your network communication will be faster. Now, what does CEF stands for? Anyone? Okay, then what about other vendors? If the labels are assigned to CEF, so Cisco Express Forwarding is the name given by Cisco for this buffer, but it is actually industrially widely used as FIB, forwarding information base. When the label is added to the FIB, it becomes label forwarding information base. Okay, so this is a very important story. Labels are not assigned to the routing table, it is assigned to the CEF entry in the CEF table. But to make understand easy to make us understand the MPLS easily in the beginning, what we say is labels are attached to the routes. Every single destination labels are attached. That is not wrong in saying the statement, but it is not to the routing table. In the CEF table only it is attached. Right. You won't get any labels in the routing table. Even if you get, is there any point in getting it in the routing table when the packets are not going to go to routing table? No. So there is no point for there is no labels found in layer 3 tables. Fine. We have learned the importance of CEF, the importance of PHP, and also we have thoroughly seen the usage of labels. I told you no routers use their own label to attach. And I also told you the label number 3, which is for PHP. But if you would like to cancel PHP, you can do so. We'll see that in the lab session. But what I'm trying to say is, no, don't cancel. It's not good, no. It is going to delay your routing process. I explained you very well why it is not recommended to have MPLS header while sending to the ultimate router. After learning all this clearly, if you say, hey, that option I want to enable, then it's, I don't understand why you want to do that. You can do it, your wish. But it is good not to have MPLS header before sending to the final router. That's why they made it as POP, the N-1 router, one router before the last router. Try to keep it as simple as possible. Now, okay, so what is going to come in the following classes? We'll have one more quick demo of the same lab what we did so that we can see these things that we have learned. Label number 3 by capturing using Wireshark, the PHP stuff, and then the CEF table with a label. After which, we'll be getting into another topic in MPLS called MPLS VPN. See, what you have learned so far is only MPLS. Very good. But with MPLS and BGP, you can achieve a lot of great things. MPLS with BGP will avoid you doing configuration, will avoid you having full mesh, will avoid you learning customer routes in every router in the provider core. Lot of benefits. So far we have seen the benefits of MPLS. So far we have seen the topic called MPLS. After a small demo of this topic which we covered today, I'll be taking you to the advance of MPLS, where we are going to learn layer 3 VPN followed by layer 2 VPN. Any question? Hmm. Hmm. Buffer. Buffer is our memory location, which is refreshable, like a random access memory. Right. Welcome. Welcome.